So here's a topic that we want to look at today. This is called scientific notation, which narrows down to a concept that is called standard form. And standard form is just a way of representing large numbers into small numbers or small representation of numbers, which is also called in a scientific way. So in every standard form, you have your answer is going to be modeling this kind of thing where you have some number multiplied by 10 raised to some power. And this power can be a negative or a positive depending on what kind of number we are dealing with, or what are the set of numbers that we're dealing with. So for example, if I'm going to do an example, let's see how can we write what we call integers in the standard form with positive powers, and then we look at how we can represent um, uh, um, any other number uh, um, having negative powers. And so let's just look at a simple example of this. So if I have 300, before I do that, let us make sure that we know these kind of, how do we represent these powers? Powers of 10. So if I have 10 raised to the 0 power, that is equal to 1. 10 raised to the first power is 10, and 10 raised to the second power is 100. 10 raised to the third power is 1,000, and it continues. 10 raised to the fourth power is 10,000, and all of that. And this is very important for us to know, because this is what we're going to use in representing our answer in standard form. So if I have 300 and I want to represent this this is in integer form, and I want to represent this in standard form, all I need to do is to put for every whole number, you can say we have a decimal point. We have zeros behind it. But this does not change the value that it is 300, because these are nothing really. These are just representing it's like a placeholder or sense or not. Well, it doesn't change or affect the original value of 300. So if I want to write this in standard form, all I need to do is to put my point right here, and I'm going to move it. I always want to move my point from the back of the number, or anywhere decimal point is, to place it between the first and the second digit. So when I do that, whenever I'm writing this in standard form, we do not put trailing zeros in our answers. Trailing zeros. Right? We do not put trailing zeros. These are called trailing zeros. These zeros are following behind the 3. It is not enclosed by any other number like this. It is not enclosed. So it is open up. They are trailing. We don't put these numbers in our answers. So to write 300 in standard form, we would do this. We move 1, 2, we put our 3 times 10 raised to, how many places did we move? We move 1, 2 raised to the second power. And that's when I was actually introducing this to you, I told that every standard form that we have will be written in this form. Some number, times, 10 raised to some number. And in this case, this number is 2. So 300 is actually 3 times 10 raised to the second power. We could even prove if this makes sense. We could prove. Now remember, this number that we have right here, we say this number is an integer. So all we're doing is converting integers into standard form. We can do the reverse of that by converting standard form into integer. Right? Let's see how it goes. So when we write 300, the answer for 300 in standard form is 3 times 10 raised to the second power. We could actually see if this is equivalent to that. What we could do, we could try to simplify 10 raised to the second power, which we know that 10 to the second power is equal to 100. And if we should simplify this, we get 100, and we have 3 times 100, which gives us 300. And it shows that they are equivalent, but one is being represented in a scientific way, while 1 is being represented in a normal way that we used to, which we call integers. Let's do another example. If I have 450 and I want to represent this in standard form, all I need to do is, so this is in integers. All I need to do is to put my decimal place point right behind the number, and I move 1, 2. I always want to start between the first digit and the second digit. And then I put my decimal place right there. We don't keep trailing zeros in our answers, but we use these zeros to count in getting the power or the index. And what I mean is this: we moved 1, 2, right? So we moved 2, so we say 10 raised to the second power. If I want to prove that this is actually this, I could do the same thing that I just did. I could just simply say this is gonna be in the 1,000. Oh, sorry, it's gonna be 100. And if I were to multiply 100 times 4.5, it will shift the decimal place 1, 2, and it will give him back 450. All right, this is another one. If I have 7017, and I want to convert this is what 37,017. Let's say I want to convert this into standard form. I want you to take a try of this and tell me what is your answer. And so I hope you got that right. So we're gonna first thing we put the decimal point right there, and we move 1, 2, 3, 4. And so we're gonna write 3.7017. In this case, we must include this 0. If this 0 is not a trailing 0, meaning if this 0 is not following behind the number, we must include the 0 in our answer. If your zeros are sandwiched or between non-zero numbers like 7 and 1, these are non-zero numbers. As long as 0 is between 2 numbers that are greater than 0, we must include that 0 in our answer. And so what we had, let's see what we had first before I added these zeros. Right. So what I had 37017. And I move my decimal place 1, 2, 3, 4. I put my point right there. My point was always between the first and the second number, and I drop all my other numbers in it times 10 raised to the fourth power because I moved the 1, 2, 3, 4. All right. Let's look at this one. 7000001. Let's write this. Let's convert this in standard form. So I would move 1, 2, 3, 4, 5, 6, 7. I would have 7 point. How many zeros do we have? 1, 2, 3, 4, 5, 6. So we must include these 6 zeros in our answers because all these numbers are between 2 numbers that are non-zero numbers. So all these zeros must be included, and we put that right there. And we say, how many places did we move? We moved 1, 2, 3, 4, 5, 6, 7, raised to the 7th power. And if I were to convert this and multiply with everything here, I would get back the same answer right there. Let's do another one. Let's look at this tricky one. 4, 5, let's say 3.47. Now, how would we do this one? Now we have our decimal place right here. It is not behind here. It is shifted it's shifted right around there. So we treat it the same way. We take the decimal point and we move it 1, 2. And so our final answer will be 4.5347 times 10 raised to how many places? 1, 2, raised to the 2nd power. If I were to convert this into 100 times this, it would give me back that. You could actually try that in your spare time. All right, so all we're doing is taking the decimal point and we are shifting the decimal point between the first and the second number. Let's try this one. What if I have 5? What would 5 be in standard form? If 5 would be in standard form, would be what? Would be 5 times 10 raised to the 0 power. What is this? 10 raised to the 0 power is actually 1. So if I were to prove that this makes sense, I will get back my 5. So in standard form, once you have just a whole number, in standard form, you would write 10 raised to the 0 power being multiplied by that digit to represent it in standard form. So that's when you have, if you look at it, all these are positive powers. All the powers that we looked at are positive powers. Let's look at this one. Let's look at this one. Let's convert this in standard form. How would I do this? 1, 2, 3. So I would 3 times that times 7. 0 must be a part of it, and 7 times. If you don't put these up, we're not going to work with these because these are trailing zeros. All right, these are trailing zeros. What we do after this, we say, how many do we move? We move 1, 2, 3. I move 10 raised to the what? Third power. You see, we have positive powers. Now let's see what happens when we're working with negative powers. When we're working with negative powers, we will have numbers looking like this. Looking at like that. And what would be the answer for this? Now, we always want to have the decimal point between the first, these kinds of number. So we would have, if we move this, we move zoop 1 time. We want to move the decimal by putting it right here 1 time. Now the answer for this would be 7 times 10 raised to the negative 1. So once you go to the right, going from the left to the right, you will have a negative power. But once you go from the right to the left, you're going to have a positive power. So the answer will be looking at that. Let's look at another one. If I have 0.00071, how would I write this in standard form? I will take my decimal point right here and I move it 1, 2, 3, and I put it right here. So I will have this right here. So bear in mind, we can't have these decimal. We can't have the decimal between 0 and a non-zero number. We can't do that. We must always have the decimal point shifting all the way, moving all the way from the zeros between two non-zero number. So if you look at it, you're seeing that the decimal point is shifted all the way between 7 and 1. And let's see how many places we move. We move 1, 2, 3, 4. And so the answer would be 7.1 times 10 raised to 1, 2, 3, 4 to the negative 4. Let's look at another one. If I have 0.000008517, and I say, represent this decimal into standard form. All I do, take my digit, my decimal place, move it. 2, 3, 4, 5, 6, stop right there. I could not leave it there because my decimal should not be between 0 and a non-zero number. It must be between two non-zero numbers. All right. So if you check out, let's see how many movements we shift this decimal point. 1, 2, 3, 4, 5, 6. So we move it 6th place. Let's recheck. 1, 2, 3, 4, 5, 6. So the answer will be 8.517 times 10 raised to the negative 6. And there you go. We're representing decimal, we're representing integers in the standard form, and it converts into positive powers and negative powers. Always remember, your decimal point should not be between 0 and any it cannot be between 0 and a non-zero number, but it must be between two non-zero numbers. Also remember, we do not include trailing zeros in our answers. But if the zeros are between two numbers that are non-zero numbers, we must include those zeros in our answers. Okay. Now,